distributive of intersection over union. This time we have the distribution of intersection over union. This is another property of the set operation, which is A intersection of B union C equals to A intersection B of union A intersection C. Last time we had distributive of union over intersection. This time we have distributive of intersection over union. So it is the distributions of intersection over union. But how are we gonna know that this left side equals to the right side? We will go for our short mathematical proof. Let me start mathematical verification. Suppose my A equals to 1, 3, 7, B equals to 2, 4, C equals to 0, 1. Let me first pick the left side, which is A intersection of B union C, plug in the value of A, which is 1, 3, 7, plug in the value of B, which is 2, 4, and plug in the value of C, which is 0, 1. First, to take the union of these two sets inside the parentheses. So the union of these two sets will be 0, 1, 2, 4. As we know that in union we take everything except the repetition of the elements. Is there any element which is repeating in both of these two sets? No, there is no such element which is repeating. So we will take all these elements of both of the sets as the union set elements. So the union of these two sets will be 0, 1, 2, 4, which is the answer for B union C. For B union C we have 0, 1, 2, 4. Now we will take the intersection of these sets, which is B union C, with the A. What is my A? My A is 1, 3, 7. Take the intersection of these two sets. The intersection will be 1. Because in intersection we take common element. What is common element? 1 is common element. So 1 will be the answer. This is going to be the answer for this whole left side. Let me give the name 1, equation number 1. Now to pick the right side, which is A intersection B of union A intersection C. Plug in the value of A, which is 1, 3, 7. Plug in the value of B, which is 2, 4. Plug in the value of A again, which is 1, 3, 7 here. Plug in the value of C, which is 0, 1. Take the intersection of these two sets together and intersection of these two sets together. So their respective intersection sets will be empty set and set 1. In intersection we take common elements. Is there any common elements in these two sets? No, there is no such element which is common. Therefore we will put empty set. Empty set is the intersection of these two sets. Here, is there any element which is common in these two sets? Yes. 1 is common. 1 is here and here. So we will pick 1 here. So for A intersection B we have empty set. This empty set is the answer for A intersection B. For A intersection C we have set 1. This 1 is the answer for A intersection C. Now we're going to take the union of these two sets. The union of these two sets. The union of A intersection B and A intersection C. So their union will be 1. In this set we don't have any element. We have only one element, which is this. So we will take it here. This is the union of this empty set and 1. This is the union of these two sets, which is the answer for this whole right side. So let me give the name equation number 2. From equation number 1, which is the left side, we got 1. Similarly, from equation number 2, which is the right side of the distributive of intersection over union property, we got also 1. So hence, from equation number 1 and 2, it is proved that this left side equals to the right side. There we got the mathematical proof from equation number 1 and 2, that this left side equals to the right side. So we have verified distributive of intersection over union property.